Hello, scholars. We're going to do a brief introduction to rational numbers through a couple of examples. Basically, a rational number is just a fraction, so we can consider rational numbers. A rational number is like a fraction, and any fraction you can sort of write it in the form of a over b, where of course b cannot be equal to 0 because then it would be something divided by 0 over 0, which we can't do. And so, for example, 1/3 is a fraction. In fact, and a rational number, 10 over 4, that's a fraction, and so forth and so on. Even negative 2/3, these are all fractions, examples of fractions or rational numbers. So one way of thinking about them, there are many different ways we're going to learn about. We can think about them as ratios, as rates. We're going to talk a little bit about proportions. But sort of as a starting place, rational numbers are numbers, okay? Which means that they're on the number line. So if I have 0, 1, 2, -1, -2, and so forth and so on, I can actually find these values, right? So 1/3 means there's one whole, and it means if I can divide that one whole into thirds, right, that's where I'll find 1/3. There it is. It's a number on the number line, right? 10/4 we could also find. We could reason that 10/4 is really 2 plus 2/4 because 2 is 8/4, so 8 plus 2 is 10, and it's okay. And 2 and 2/4 is really 2.5, so 10/4 we'd actually find it somewhere over here. And then the fraction -2/3, well, it's going to be negative towards -1. And again, we're dividing this up into thirds, and this is the location on the number line. Okay, this is a very, very quick sort of review. So the big idea is that fractions, or that rational numbers, are numbers on a number line. Okay, so let's take a look at a couple examples. So example number 1, Theodore is a baby. He grows 1/3 of an inch every month. If this rate of growth continues, then how many inches will he grow in 2 years? Okay, so we can think about this as there's 1 month, and at that time, he grows 1/3 of an inch, right? That's basically what we're saying. Every month is worth 1/3 of an inch. And it's asking, let's see, how many inches will he grow in 2 years? Well, how many months is 2 years? Well, there's 12 months in 1 year, so there's got to be 24 months in 2 years, right? Okay, that's fine. This is actually a proportion. We'll get to that. But yeah, there's 24 months in 2 years. So the question really is, if 1 month is worth 1/3 of an inch, how much is 24 months, right? If we had 1, 2, 3, all the way to 24. Well, if everyone is worth 1/3 of an inch, 24 of them would be worth 24 of them, right? Of is multiply, right? So 24 of these thirds of an inches. That's how much he's growing. He's growing 1/3 of an inch 24 times. And this one, we can just actually, 24 thirds, 24 of these things that are 1/3 is equivalent to 24 thirds. We write it that way. And since we know that the fraction a over b, it's the same thing. It's the same thing as a divided by b, right? It's just a different way of writing it. That's why the division sign looks the way it does. It looks like there's a fraction bar there. So 24 over 3 is nothing more than 24 divided by 3, which is 8. So the answer is he'll grow 8 inches. Okay, so that's an example where, although we have a rational number in there, which is 1/3, we're just treating it like a number, right? I could have said he grows 5 inches every month, and then you do 5 times 24 to get the answer for how many does he grow in 2 years. Okay, let's take a look at another example. So example number 2, a cake recipe uses 3/2 cups of sugar. So again, this is just a number. We could represent it as, imagine that this is 1 cup, and 3/2, right? 3/2 is really 2/2, which is 1, plus another half, right? So that would be 1 cup plus we could say this is like a half of a cup. Okay? And we could also look at it at 3/2. We could also rewrite it as, for example, 3/2. Okay, we'll get into all this later, but we're basically saying we have 3 of these things that are halves of a cup. Okay, the cake is divided into 6 pieces. How many cups of sugar are in one piece of this cake? So if this represents the whole cake, one cake has 3/2, all of this sugar, right? This is the amount of sugar. Okay, and it's divided into 6 pieces. Well, we're going to say equally sized pieces, right? We're not making like big cakes and small cakes or small cake pieces. No, they're equally sized pieces. So to divide this up into 6, well, first off, let's try to get them all equally sized to half of a cup. So I can do that by dividing the 1 cup in half. So now we have 3, you see 1, 2, 3 equal sized pieces. Each one of those is 1/2 of a cup. And so we're on our way, but we want to divide it into 6. So let's just divide each of these in half again, right? So we could say, let's divide that one in half, that one in half, that one in half. Now we have 6 pieces. 1, 2, 3, 4, 5, 6. I'm just counting them here, right? And each of those pieces is half of 1/2 of a cup. So what is half of a half? That's a quarter, right? A quarter of a cup. So our answer is 1/4 of a cup. And if you say, wait a minute, isn't there a better way of, or not a better way, but is there a way of doing this using sort of arithmetic that has a flavor of algebra to it? And you bet there is. If I start with 3/2 and I am saying that I'm dividing it into 6 pieces, I can rewrite this as 3/2 divided by 6. This is nothing more than 3/2 over 6. Okay, these are the same things, same way of writing them. I could also write it as 1/6 of 3/2, right? When I divide something into 6 pieces, I am taking 1/6, right? This is 1/6 of the entire cake in this case, right? All the sugar in the entire cake. So all of these, right? I can, in fact, just use arithmetic. When I multiply fractions, you multiply across. That ends up being 3. 6 times 2 is 12. And 3/12 is, in fact, equal to 1/4, right? These are the same numbers. Rational numbers are a little crazy, right? Because I can have 1/4 equaling a different rational number, equaling a different rational number, equaling a different rational number, and we say, well, how far could I go? How many different numbers could I use when their ratio, right, is the same as 1/4? And the answer is I can go on forever, right? There's an infinite number, an infinite amount. In fact, if I take any 2 of these equalities, or if I take any 2 of these numbers and show that they're equal, this is a proportion. So let's take a look at a proportion. One quick example. So a proportion. While walking in Prospect Park one day, you noticed that you cast a 20-foot shadow on the ground, even though you are only 5 feet tall. So what does that look like? Here you are. You are 5 feet tall from head to toe. And you write the sun is somewhere. There's the sun. Very nice sun. And the sun rays go down, right? And the shadow we're talking about is basically this distance right here. This is on the ground. This is the shadow, okay? And the shadow in this case we said is 20 feet long, okay? So there we are. Here's our picture. And the question is, as you walk past a shrub, so a shrub is nothing more than a bush, right? So it could be like a bush. Here's our little shrub, right? Very good. You measure that its shadow, so the shrub shadow is 32 feet long. So we can also imagine that the sun, right, is also going on to the shrub, and it's making this shadow right here on the ground, and this one right here is 32 feet. Question is, how tall is the shrub? Right? So they're asking basically, what is x? How tall is this thing? Right? Well, here's one way you can think about it. If 5 feet of you makes a 20-foot shadow, how much does each foot of you make? In other words, if 5 feet of you make a 20-foot shadow, how much does each foot? How much would 1 foot make? How much of a shadow would 1 foot make? And we can do our cross-multiplying thing or whatever. We can just think about it, right? 5 to 20 is the same as 1 to 4. Okay, so this is you, and this is the shadow. So one way we can reason about this problem is that every foot of you is worth 4 feet of the shadow. That's good. And then we can go back here and say, well, we'd have our ratio of 1 to 4, which is the height to shadow, right? Here's our ratio of 1 to 4, and we say, well, now we have a 32-foot shadow. So how high is this thing, right? And we can cross-multiply if we wanted to, but we can also just think about it in the following way. Well, if I have 4 here, how many times bigger am I making my 4-foot shadow, right, to get to 32? 8 times bigger. Okay, well, if the shadow's getting 8 times bigger, the height has got to be getting 8 times bigger as well. And so our answer in this case is going to be that x is 8 feet. And we can sort of capture now these 4 numbers, right? So we had a 20 and a 5 and a 32, and our answer was 8. That's a proportion, right? We could say that 5 over 20 equals 8 over 32. And in fact, they both equal 1/4.